Okay, 2.6.2, we are solving rational inequalities. Well, first of all, rational means can be written as a fraction. Inequalities are things like this. 2n minus 3 is less than, let's say, 7. And that's an inequality. But a rational inequality would mean that this whole thing was a fraction. All right. So, like for instance, let's say we put it over 5. Now, if you're solving this, I want to clarify that you are going to be like not just treating them like they're equations. All of a sudden, there's a new rule, and that is that we don't want to multiply by a variable on both sides of an inequality. Let me try to explain why. If I was solving this one, I'm adding 3 to both sides, and I have 2n is less than 10. I divide by 2 on both sides. I have n is less than 5. That all worked. It's correct. This is the right solution set. If I was going to like graph it, it would go like this. Here's 5, and it's less than 5. So things like 4 and 3 and 2 and 1 work. Now, what if it had been negative? If it had been negative right here, negative 2n, you'd have to divide both sides by a negative, and then you'd have to switch the sign around. It would have to be greater than 5. So you're thinking, well, yeah, I've seen that before. There's nothing new here. I understand why you'd be thinking that. But if I were to prove that this is really correct, I'm going to take 6 here. I'm going to put a 6 right here. We're just going to prove that my solution set is right. This will be negative 12 minus 3, which makes negative 15 is less than 7. Well, again, it's working. So you did it right, Mr. Server. When you divided by a negative, you switched the sign around. It went from less than to greater than. And that's correct. But here's the catch. You can't multiply or divide by a variable when you're doing a problem like this. Like let's say I had x is less than 5. And I multiply both sides by a variable. If I multiply both sides by x, and I try to solve it now, the problem is I don't know if I just multiplied or divided this by a negative, because that x could have a positive or a negative number in it. And therefore, I don't know whether to switch the sign or not. All right, so moral of the story. Even though you might be tempted later in the lesson to multiply or divide by a variable when you're doing an inequality, you can't do it because you don't know whether or not that variable could have a negative number in it, which could make the sign switch, and then it's not going to be true anymore. All right, so now I know there's some really smart kids in here that are going to be wondering, okay, why can't you do that again? Why can't you multiply by a variable on both sides? Let me just finish this off. I think you'd agree that x times x is x squared is less than 5x. Then I'm going to have to subtract 5x from both sides. And then I'll have x squared minus 5x is less than 0. Now I'm going to factor it. X, parentheses, x minus 5 is less than 0. And now I would need to find, we solved some like this the other day. Like when we started with a problem like this, and we solve it, we find the things that make it 0, which are 0 and 5. We circle them. And then if it's less than 0, it can't be 0 and it can't be 5. Like if this had been or equal, we would fill those things in. And now we test intervals and we see like, well, I wonder if it's going to work in here. So let's try like 2. If I put a 2 here and a 2 here, I have 2 times 2 minus 5 is negative 3, and that's negative 6. Is that less than 0? Yeah, it works. But this implies that it only works between 0 and 5. I started with the statement x is less than 5, which would be true for forever, all the numbers that are less than 5. And when I multiply both sides by x, I'm left with this. And again, you try sticking negative 1 in, and you realize that if I put in a negative 1 here and a negative 1 here, then all of a sudden I have a negative times a negative, which makes a positive, and that's not less than 0. and it implies it doesn't work there. Okay, so moral of the story. In case you wondered why can't you multiply both sides by a variable? Because of things like this. All of a sudden we came up with a statement that only works between 0 and 5. When the original problem, you could have had any negative number and it still would have been less than 5. And it's a totally different answer. So don't multiply or divide by variables when you have inequalities. All right, so I'm going to skip over this slide. We're going to go to this one. Everybody find this one in the notes. Now, I taught you the other day that, of course, if you can factor it, you should. And you factor those problems. This time they look like fractions. Last time it was just like you'd factor something and it would look like this. And there wasn't any fraction involved. Well, now we're going to still factor them, but there's a fraction involved. And so, of course, that's more complicated for rational functions. And if you're decent at factoring by now, you've probably already factored the bottom, and there you go. Now, we can't just treat these like the ones that we had the other day because of the fact this is an inequality. We can't multiply or divide. So the other day I was telling you, got to clear the fractions. No, can't clear the fractions on something like this because we'd be multiplying by a variable on both sides. And I just showed you how that doesn't work with inequalities. All right, so far, all you've had to do is factor this thing. It's not that hard. But now what you need to do is figure out the zeros. That's what makes the top zero. Well, it's not too hard. What makes the top zero is if I put in -1. So that's one of my key numbers. And I think the only way to do this is to put that on a number line. Circle it. And if it says or equal to 0, we know that this makes it equal 0. That's the whole point. If the top of the fraction equals 0, it doesn't matter what the bottom is, the whole thing will equal 0. And isn't that good? Yeah, because look, this is an or equal to problem. And so it wants it to equal 0. So yay, it works. Okay, so -1 is one of my key spots, and I fill it in because it makes it equal 0. All right, then it says calculate the undefined values, the things that make the denominator 0. Would you agree that x equals -2 makes the bottom 0, and x equals +2 makes the bottom 0? So those are obviously important. Here's where -2 lives, and here's where +2 lives. Now, do these make it less than or equal to 0? No. These are what's called undefineds. I like to put a little u above them so that you don't by accident fill them in. Because if you stick in -2 in your equation, look, right here, you'd have a 0 on the bottom, and that means that that fraction can't exist. So you don't want to fill it in and act like -2 is one of your solutions, because -2 won't work. All right, so now that I've found the things that make the top 0, found the things that make the bottom 0, now I have to test intervals to see which ones work. So there's a whole bunch of possible intervals here. There's the numbers bigger than 2, the numbers in here, the numbers in here, or the numbers in here. And that's the part most kids will get wrong on the test. Most kids will be able to figure out what makes the top 0, what makes the bottom 0. Sometimes kids fill them in when they shouldn't. You know, remember, the ones that make the bottom 0, you should not fill those in. They are not solutions. They kill your function. So they stay empty, like these two stay empty. But the most common mistake is in this testing part. So I'm going to take it slow and careful, and I'm going to test the number 3 here. So I'm going to go put a 3 in, because I'm testing this interval of the numbers bigger than 2. So if I go to put a 3 in, I put a 3 here, and here, and here. It's getting a little messy, but I'm going to clean it up over here. And I'm going to want you to note that I don't even care what the number is. I just care if it's positive or not. I know this is +4, but really all I care is that it comes out positive when I stick a 3 in. Over that comes out positive, and that comes out positive. 3 minus 2 is positive. Again, you could put numbers there if you wanted to, but you're just making your life more complicated, because we're always going to be comparing these things to 0. So all we care is, did our answer come out positive or negative? And if it's positive, 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 well, obviously, then our answer came out positive. And that is not less than or equal to 0. So that was a fail. It came out positive, and that's not what we wanted. We wanted things less than or equal to 0. All right, so it did not work in this area because when 3 was tested, it gave us a positive answer, but positive is not what we wanted. We wanted less than or equal to 0. All right, I've been talking a lot, and I hope that you have been paying really good attention. So far, we just figure out the things that make the top 0, the things that make the bottom 0, figure out whether to fill in those spots or not, and now we're testing numbers, and we get a little chart like this where it's positive over positive and positive over negative, and we figure out if the thing actually equals or is less than or equal to 0. All right, so again, I'm going to refactor it here, and I want you to test the remaining intervals here and here. The only number between -1 and 2 is -1.5. I mean, there's more, but might as well use that one. Test these 3 intervals and see if you think that it came out positive or negative, and therefore did it work. By work, we mean, did it come out less than or equal to 0? And if it did, you fill in that part of the number line. All right, I'll be quiet again, and I want you to test those intervals. Okay, I think you probably tested 0 to check this interval. Now, you might have tested some other number, and it's okay. We'll see if 0 works. This came out positive on top. Remember, it's +1, but I don't care. It's just positive. This came out negative, and this came out positive. When you multiply in one negative into a problem, you get a negative, right? So this is going to come out negative, as in less than or equal to 0. And that's what we wanted. So this zone worked. Okay. How about -1.5? When you put in -1.5, and we're testing that interval, all we care about again is, does it come out positive or negative? The top comes out negative, and the bottom, we've got a negative times a positive. That's going to have 2 negatives in it, which means the answer to this whole thing comes out positive, which is not less than or equal to 0. So this area does not work because it comes out negative in there. Or sorry, because it comes out positive in there. Sorry about that. This area came out negative, and that's what we wanted, and so we filled it in. All right, last but not least, we check -3. I bet most of you did use -3. And now I'm going to use it back in the original problem. I'm just going to show you that this could work. That comes out negative. That comes out to be +9 minus 4. 9 minus 4 is a positive. So it was a negative over a positive. A negative over a positive gives you a negative answer, which will be less than or equal to 0, so it works there. So it works out here. Now, if you were forced to give your answer as an interval, interval notation would be from -infinity until -2. It works. It doesn't work at -2 because it's undefined there. Then it starts working again at -1, and it's a bracket because -1 makes this thing equal 0. It's the thing that made the top 0. All the way till 2, and we're at 2, it doesn't work again. So we put a parenthesis there. Why doesn't 2 work? Because it's undefined there, because when you stick a 2 in, it makes the bottom 0. All right, so that is not easy, but hey, you signed up for precalc. This is a challenging class from time to time. Let's go to the second page of the notes here. So, I never even noticed that this problem is basically it's the exact same thing with a different sign. Okay, so it seems kind of dumb to redo the same exact problem with just a different sign. Let's go to the next one. How about this one? Well, pro tip, we need to get a common denominator. I know it's going to be a little bit of a pain, but to be able to put this all together, we need a common denominator and put all of this fraction together. All right, so to be able to do that, everybody take a second and multiply by what I call the other denominator. So for example, on the left side here, to get these two to have a common denominator, I'm going to take this denominator and multiply by it here and here. And then over on the other side, I'm going to multiply by the other denominator. Now, why did I do that? Because I now have a common denominator of x minus 1 times x plus 3. See? They have a common denominator. And that allows me to actually add them together. So this is the part where I'm going to multiply that all out, multiply this all out, and put it all together on the top. And I know the bottom has a common denominator of x minus 1 and x plus 3. Common rookie mistake is to multiply that out. But remember, at the end, I always tell you, if you can factor it, you should. So you should leave it factored. All right, take a second, and everybody multiply this all out, multiply this all out, and add it all together and put it on the top. Now pause for a second while you give that a try. All right, so you should have had 5x minus 5 for this one, and this is 3x plus 9, and then the 5x and the 3x makes 8x, and the plus 9 and the minus 5 makes plus 4. All right, and then that can be factored, and if you can factor it, you should. So you factor out the 4, and you have 2x plus 1. See, multiply that out, I get 8x. Multiply that out, I get 4. So there, it's been factored. So now it's factored on the top and it's factored on the bottom. So that's the first step in these problems, is to get it all into one big fraction. And now, let's just try to be really clear here. What were we trying to find in the first place? See that less than 0? I'm going to put that back in here. We're trying to find where this fraction is less than 0. Okay, now you're going to figure out the things that make the numerator 0. Then you're going to figure out what makes the denominator 0. And then we test those intervals. And on that number line, try to figure out what zones work. All right, well, what makes the top 0? 2x plus 1 needs to equal 0, so 2x needs to equal negative 1, and x needs to be negative 1/2. Guessing some of you beat me to that. This one, x equals 1 is important because it makes the bottom 0. X equals negative 3 is also important. It also makes the denominator 0. So these are my 3 key points, but that one is a 0, as in it makes the equation 0, and that's important. And this just makes the equation die, and so does that. But if I put them all on a number line, here is negative 3, here is negative 1/2, and here is 1. And the negative 1/2 made it 0. These two make it undefined, and none of those work. Because if it's undefined, it killed the function, and that won't make it less than 0. It'll kill it. And if it's a 0, like this one, like the thing that made the top 0, the thing that made the top 0 was negative 1/2. That'll make it 0 is less than 0, and that's not true, of course. All right, so it doesn't work. We leave these empty circles. Then you have to test the intervals. All right, so now we're going to test a number like 2, because that's, in that interval. This is a little weird, but what's between negative 1/2 and 1? Oh, 0, my favorite thing to test. Super easy. Test negative 2 because it's in there, and maybe test negative 4. When we're testing them, I would not put it back in the original I would put it back in the factored form one. I think you'll find that it's a lot easier to put it in this one. And remember, we only care if our answer comes out positive or negative. So no need to tell me it came out to 8/3. It's just, did it come out positive or did it come out negative? And then if they come out less than 0, you fill that spot in on the number line. All right, I'm going to start with this 1 here. No, I'm sorry, we're not testing 1. We already knew 1 didn't work because that made the bottom 0. I'm going to test 0 first. I'm going to test 0. So I'm going to go take this equation and I'm going to put it back here. And then I'm going to, just above the variables, I'm going to put in the number I want to check. And now let's see if that comes out less than 0. Remember, that was the original problem right up there. We wanted to see if it came out less than 0. So this comes out positive over negative, positive. Positive over negative, positive. If there's only one negative sign, then it comes out negative. Is that less than 0? Yes, it is. So I tested in here and it worked. All right, now I'm going to test 2. I'm going back in here, here, and here, and I'm going to test a 2. Remember, all I care is, does it come out positive or negative? That comes out positive. Okay, this one comes out positive, and this one comes out positive. They're all positive numbers. Positive over positive, positive. That's all positive. That means it's not less than 0. So since it comes out positive, when I put in 2, it comes out positive here. I don't want that because I was looking for things that were less than 0. So it does not work here. All right, next is testing -2. I'm going to go test -2. Easy to forge in a negative sign here on all of them. Now this will come out to -4 plus 1 is -3 times 4 is still negative. Negative over, that comes out negative, -3 to be exact. And this comes out positive. So that's going to give us 2 negatives and 1 positive, and that turns into positive. And positives are not less than 0. So I stuck in -2, and it came out positive. And that's not what I want. Okay, and now let's test -4, the last number. So I'm going to go put a -4 in all of these spots. -4, -4, and -4. And this comes out -8 plus 1 is -9 times it by 4. It's still negative. Okay, so it's negative on the top. This one's going to be negative because it'll be like -5. And this will be negative. It's negative, negative, negative. That means that there's 1 negative on top and 2 negatives on the bottom. That means that this whole thing, when there's 3 of them, it comes out negative. 2 of the negatives will cancel, leaving 1 behind. So you got a negative answer. Is that less than 0? Yes, it is. This came out negative, and that's what I wanted. I wanted things that were less than 0. So it worked in there. Okay, and I am totally okay with your answers having number lines like this. So, big picture, what do? You have to add your fractions together with a common denominator. Then you have to factor it. Then you have to figure out what makes the top 0, figure out what makes the bottom 0, and then test intervals on a number line. Let's get to your homework. We'll get out your homework here. And the first problem in your homework looks like this. I will do it with you. So it's already factored on top, cool. On the bottom, it factors to x plus 3 and x minus 3. and we want things that are less than 0. Well, I can just in my head figure out what makes the top 0 and put it on my number line. -2 is important, and it makes it equal 0. That's important. The things that make the top 0 are called zeros. They make the whole equation 0, because 0 divided by anything is 0. That's different than this, which gives us -3, because that's undefined. When you put in -3, you will kill this function. So -3 does not work. All right, and last but not least is +3, which would be like way over here. And +3 would also kill this function, so it's undefined. I'm not going to make you write a U above that, but it's a good idea. It reminds you that that's a spot where it's undefined. All right, this one spot where it was equal to 0, that's not less than 0. That's what we want. We want less than 0. So it doesn't work on any of these spots. And now you would test intervals. You would test the number 4, and put it here, 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 and you come out with positive over positive, positive. Well, that's all positive. And that means it comes out positive, which is not less than 0. Not what we wanted. So I cross this area out. It doesn't work. It comes out positive, which in this case is a bad thing because we wanted things that were less than 0. One more. Let's test this spot. Let's test 0. Putting a 0 here, here, here. We're going to get positive over positive, negative. Positive over positive, negative. That has only one negative in it. That's going to come out negative. And that's what we want. We wanted things that were less than 0. So I'm filling it in. Now you'd want to test -2.5, maybe -4, see if they work, and therefore whether it comes out positive or negative, and therefore whether you should fill it in. All right, so I'm committed to keeping your homework reasonably sized. So what I think you should just do is do the odd problems on this worksheet. So I helped you with number 1 there. Obviously, you can go on to number 3. The factoring is just a little more complicated, but it's the same basic process. Almost every kid figures out what makes the top 0, what makes the bottom 0, and sometimes there's 2 or 3 different numbers, maybe even 4 numbers. Most people find those numbers. It's testing the intervals that gets the tricky part. All right, so you're just doing the odds in this worksheet. So this is the part where if I were you, don't forget when you get here that you need to get a common denominator first so that these fractions can be added together. It won't work unless you've got a common denominator and therefore you have an actual rational function. If you multiply that all out and add it all up, then you'll have one fraction to rule them all. And then you can start the process of factoring it, figure out what makes a top 0, what makes a bottom 0, etc. All right, so we're just doing the odds, which also means you're doing number 11. And that's all I got for you for today.